In the polynomial x to the fourth minus 18x cubed plus kx squared plus 200x minus 1984 is equal to 0. The product of two of its roots is negative 32. Find k. Okay, so for this problem, I think that the best way to solve it is using Vieta's formulas. And in case you don't know what that is, I'm gonna explain that right over here. So, for example, for this polynomial, x cubed plus rx squared plus x plus s times x plus t is equal to 0. And let's say the roots of this polynomial are a, b, and c. So a plus b plus c is going to equal negative in front of this one divided by the coefficient in front of this x cubed term. And then it's going to alternate. So basically for the pairwise sum, it's going to be so it's going to be negative here. So think about it like this. It's negative, positive, negative, positive, and so on. So for the sum, it's always going to start with the sum. It's going to be negative r divided by this coefficient here, and then positive s for the pairwise sum divided by this 1 over here, which is just s, and then the product would be negative t divided by 1, because you always alternate the signs, divided by the 1 here, which is just negative t. So for instance, for this polynomial, x cubed minus 5x squared plus 4x plus 2 is equal to 0. So we basically alternate signs starting from here, negative, positive, negative, and so on. So yeah, so it would be for the sum, it would be 5. A negative of a negative 5 is just positive 5. And then the pairwise would be 4, because positive 4. And then the product of the roots, because remember, a, b, and c are the roots of this polynomial. So the product of the roots would be negative 2 over 1, which is just negative 2. So it works exactly the same way for the fourth root as well, except that you just alternate more signs and you have like a triple pairwise too, so you have to account for that. So this problem involves a fourth root. So what I did was I just used Vieta's formulas again, and then the sum would just be negative of negative 18, because remember, it always starts with a negative here and then positive, negative, positive, and so on. It works exactly the same way for x to the fourth polynomials as well. So the sum would be negative of a negative 18 divided by the 1 in front of this x to the fourth, which is just 18. The pairwise, now remember, this is the double pairwise and this is the triple pairwise. So that does not exist for these polynomials, x to the cube. Like for these polynomials, there's no pairwise, like there's not like two pairwise. But here you're going to have, for x to the fourth, you're going to have two pairwise. So you have to also account for that. So these are triple pairwise and this is just double pairwise. So for double pairwise, I would just equal it to positive k divided by positive 1, which is just k, right? Triple pairwise would be negative 200, because this is negative, because negative, positive, negative, divided by 1, which is just negative 200. And finally, the product would just be negative 1984. But remember, there's a positive here, and positive and negative is just a negative. So negative 1984 divided by 1, which is a negative 1984. Okay. So we have our Vieta's equations down. So now we can proceed with the problem. The problem is asking for k, right? So this, we notice that the second equation here involves k. So we're most likely going to be dealing with this one, but we're also going to likely be using the other equations. So the product of two of its roots is negative 32. Okay. So basically what I did was I said CD is equal to negative 32, because these are two of the roots of this polynomial. And then the other two roots, so CDEF is equal to negative 1984. And if CD is equal to negative 32, then the product of E and F is going to be negative 1984 divided by negative 32, which would be positive 62. And I did the division right here. Okay. So we can factor this out. What I basically did was I factored out the third equation here in terms of E, F, C, and D. So C and D are common for these first two, and then for the last two, E and F are common. So I can do CD times E plus F plus EF times C plus D. And why I basically did that is because I know the values of C, D, and EF, which is negative 32 and 62 respectively. So negative 32 times E plus F plus 62 times C plus D is equal to negative 200. Okay. And now what I'm trying to do is I'm trying to simplify this even more. E, F, C, D. There's 4 different variables here, 4 different roots, right? And what I'm trying to do is like simplify this even more in terms of like 2 variables at the most. basically what I did was I used the first equation here, which is I did it in terms of C and D, but you could also do it the alternate way in terms of E and F. So I could C plus D could equal 18 minus E minus F, and I could substitute that here. But I did it in terms of C and D, which is perfectly fine. 18 minus C minus D is equal to E plus F. I did that substitution to try to simplify this even more. And then I get negative 32, substitute that, plus 62 times C plus D is equal to negative 200. And I can expand this out. Negative 576 plus 32C plus 32D plus 62C plus 62D is equal to negative 200. And then I can combine like terms and move the constants on one side. So I get 94C plus 94D is equal to 376. And what I'm trying to solve for essentially here is I can solve for C plus D here, right? And from C plus D, I can also get E plus F, because remember, E plus F is equal to 18 minus C minus D. So I can get E plus F easily. And why I'm basically trying to solve for E plus F and C plus D is because ultimately, I'm trying to solve for K, right? And I can simplify this second equation, because this is the only equation that involves K. So I know for a fact that I'm going to be using this equation. And I can simplify this in terms of C, D, E, F, and in terms of E plus F and C plus D, since I know the numerical values of those terms. And essentially, I'm trying to get my final answer in terms of a number. It says find K, so it's in terms of a number. So I can simplify this second equation to basically where it is. This is the second equation. CD plus CE plus CF plus DE plus DF plus EF is equal to K. And then what I can do is CD and EF. I know those, so I can leave those as they are. And then here, what I see in these four terms, I see a C and a D in common. And remember, I'm always trying to get it in terms of these four terms here. So C and D, right? C plus D times E plus F. This is how I simplified these four terms in the middle here. The C, D, and EF, I leave them alone because I already know their values. Why would I simplify that even more? I already know those values, and my final answer is numerical. So I leave the first and the last term alone in the second equation, and then I can simplify the middle. So basically, I have C plus D and E. I have my solution in terms of what I want. I know the numbers for these, and that's exactly what I did. I substituted the numbers back again, and I got K is equal to 30 plus 56, which is equal to 86, which is my final answer. So remember that I'm trying to always look at the problem and see what I'm trying to solve for, which is K, and I'm not trying to use equations that I don't need. So I first try to see this equation. This is the equation that I need too. And I'm trying to see that what variables I need to solve for in order to finally get my answer K in terms of a number, not in terms of variables, but in terms of a number. I hope that helps. And if there are any errors or any mistakes that I made in this video of this 1984 USAMO problem, please let me know. Thank you.